DBSCAN clustering. Algorithm DBSCAN density-based spatial clustering of applications with noise. Pseudocode steps. 1. Data preprocessing. Description: prepare the data for clustering by handling missing values, encoding categorical variables, and scaling numerical features. Steps. Handle missing values imputation. Details: replace missing values using mean, median, or interpolation methods. Encode categorical variables if necessary. One-hot encoding. Label encoding. Details: convert categorical variables into numerical format suitable for clustering algorithms. Scale numerical features: standardization or normalization. Details: standardize features to have zero mean and unit variance or normalize them to a fixed range. 2. Model training and clustering. Description: train the DBSCAN model using the preprocessed data. Steps. Initialize parameters. Details: set epsilon neighborhood radius and minimum points min/pts parameters. Calculate core points. Details: identify points with at least min/pts neighbors within epsilon distance as core points. Form clusters. Details: form clusters by connecting core points and their reachable neighbors. Assign border points to the nearest core points cluster. Label points as noise if they are neither core nor border points. 3. Evaluation and validation. Description: evaluate the clustering results using various metrics and techniques. Steps. Evaluate clustering quality using metrics like silhouette score, adjusted rand index, or Davies-Bouldin index. Details. Silhouette score measures how similar a point is to its own cluster compared to other clusters. Higher values indicate well-defined clusters. Adjusted rand index measures the similarity between two clusterings, correcting for chance. Davies-Bouldin index measures the average similarity between clusters, with lower values indicating better clustering. Handle noise and outlier detection through cluster analysis or outlier detection methods. Details: identify and manage noise and outliers using techniques like DBSCAN or robust clustering. Methods. Assess cluster stability and robustness. Details: monitor how clusters change over time and evaluate results across different datasets to ensure consistency. 4. Handling categorical variables. Description: process categorical variables appropriately for clustering. Steps. Encode categorical variables using suitable techniques. One-hot encoding. Label encoding. Details. One-hot encoding: convert categorical variables to binary vectors. Label encoding: assign a unique integer to each category. 5. Fine-tuning and optimization. Description: optimize model parameters and settings for better performance. Steps. Fine-tune epsilon and min/pts parameters based on evaluation metrics and domain knowledge. Details. Adjust epsilon to control the neighborhood size for density estimation. Modify min/pts to define what constitutes a core point. Adjust distance metrics or clustering criteria to optimize performance. Details: experiment with different distance metrics, e.g., Euclidean, cosine, to improve clustering results. 6. Handling uncertainty and drifts. Description: manage uncertainty and detect concept drift in the clustering process. Steps. Monitor cluster stability over time to detect concept drift. Details: use statistical tests or monitoring systems to detect changes in data distribution. Implement re-clustering strategies or update clustering parameters based on drift detection. Details: adapt clustering parameters or retrain the model when significant concept drift is detected. 7. Test case criteria. Description: define test cases to validate and assess clustering results. Steps. Define test cases to validate clustering results against known ground truth or domain knowledge. Details select datasets with known cluster structures and validate the clustering results. Evaluate clustering robustness across different datasets or subsets. Details test the algorithm's performance on diverse datasets to ensure its generalizability and robustness. Evaluation metric. Description metrics to evaluate the quality and performance of clustering. Metrics. Silhouette score. Details measures how similar a point is to its own cluster compared to other clusters. Higher values indicate better defined clusters. Adjusted RAND index. Details measures similarity between two clusterings. Correcting for chance. Values range from -1 to 1, with 1 indicating perfect agreement. Davies-Bouldin index. Details evaluates the average similarity between clusters. Lower values indicate better clustering quality.